probably already know what efficiency is, but this is a quick little review to get things started. Efficiency is a ratio. It's one thing divided by something else. It's a ratio of what you get out of a machine to what you put into a machine. So that's it. That is efficiency. Now, quite often people want to hear efficiency as a percentage. So what we do is we just multiply this by 100, and our answer is a percent. So why would you want to solve for efficiency? Well, the gas mileage of your car, that is an efficiency rating of your car. So like if you put in a lot of gas and you get out a very little bit of motion, then you get a small number for your answer. But if you think, well, I'm going to put in a lot of gas and I'm going to get out a lot of motion, then I'm going to get a big number for my efficiency. Just to make up some examples here, let's say a lot of gas is represented by 10, I don't know. And let's say a little bit of motion is represented by 2. So 2 divided by 10 is 0.2. Multiply that by 100. 0.2 times 100 is 20. So we're just going to say this is 20%. And then let's say, once again down here, a lot of gas is 10. And let's say a lot of motion is 8. So 8 divided by 10 is 0.8. 0.8 times 100 is 80%. So that is basically the nuts and bolts of the efficiency equation. So when you make a machine, what you want to do is you want to make sure that what you put in is maximized. You want to get the most out. Like I just snooped around and found this video. Check this out. This is a robotic, kind of a mule device developed for the military for carrying equipment and stuff. Just imagine machine guns on it. Anyway, so check this out. It falls over, stands up. Can you hear the motor in the background? Can you hear the generator powering this thing? It's easy to get stuck watching this because it's so awesome. Anyway, what you want to make sure is that when you put in fuel, you want to get the most out. You want a very efficient machine. So let's just solve a couple problems here to make sure we know how to do it. Let's see, I'm going to write out over in times 100 equals efficiency. Okay, so let's just say that we put in 30 joules worth of fuel. Joules is the energy of the fuel. And let's say that we get out 10 joules worth of work. So in this case, let me switch my colors here. So in was fuel and out was work. So the machine did some work for us. What is the efficiency? Well, all we have to do is plug in our numbers. We've got our output of 10 joules. Our input was 30 joules. So joules are going to cancel. And then we're going to multiply that by 100. So just doing this, 10 divided by 30, what is that? Well, we can cancel out the zeros here. 1 divided by 3 is 1/3, so that's 0.3 repeating. Times 100, that is a 33.3% efficient machine. Okay, when you solve problems for efficiency, your answer will always be some number that is less than 100. Why? Because if it were greater, then you could put in 30 joules worth of fuel and get out 31 joules of work. And that's just not possible. So your answer for efficiency is always going to be some number less than 100. Okay, so let's do one where we say that we know the efficiency. Let's say we have a 25% efficient machine and we put in 500 joules worth of fuel. So what we want this time is we want to get the output by itself. So that means we have to do a little bit of algebra. So let me rewrite this. I'm going to write E equals O times 100 over I. And I'm trying to get O by itself. So I am going to get rid of this divided I. I'm going to multiply both sides by I. So I times E equals O times 100. And I'm trying to get the O by itself. So now I've got this multiplied 100. So I'm going to divide both sides by 100. Cancel it out there. All right, so what I wind up with is, ooh, terrible color for that. Don't highlight with that color. How about this color? All right, so that means that O is I times E over 100. So let's see what we get here. I is 500. E was 25 divided by 100. So let's see here. Grab my calculator really quickly just in case I mess up the math. So I'm going to go 500 times 25 equals divided by 100, and I get 125. 125 joules. So if you put 500 joules into a 25% efficient machine, you will get out 125 joules worth of work. Okay? So the last kind of problem I could make here, the last flavor, I guess, would be where we had to figure out the input. So let's say we got 75 joules worth of work out of a machine, and that machine was 10% efficient. That means we want to get I by itself. So we know that efficiency is output over input times 100. So we want to get the I by itself. Well, I'm going to rewrite this. I don't like those parentheses. So I'm going to go E equals O times 100 over I. So how do you get I by itself when it's down here on the bottom? It's divided. Well, what I'm going to do is I'm going to multiply both sides by I. It cancels it out here, and it shows up there. So I times E equals O times 100. And then what I'm going to do next is, since I want I by itself, I want to get rid of this multiplied E. So I'm going to divide by E. And what I wind up with is I equals O times 100 over E. So let's plug in our numbers and see what we get here. O was 75 times 100 divided by the efficiency. I think I can do this without the calculator. 75 times 100 is 7,500. Divided by 10 is 750 joules. So if you got 75 joules worth of work out of a 10% efficient machine, then how much fuel must you have put into it? You must have put in 750 joules. Maybe this is a problem you could have done in your head without a calculator, but there you go. There's an example of solving some efficiency problems.